Okay, let's quickly see today what are the products between vectors, the dot product and cross product. Let's start off with the dot product, the more easier and the intuitive one. So I've got two vectors over here, x bar and y bar, and then when you say x bar dot y bar, the definition is the magnitude of x, magnitude of y, and the angle between them, cos theta over here, right? So this is the definition, and it can be proven by taking this to be an angle and this to be another angle, and cos, subtract these two and things like that. But we'll not go into the proof of it, but yeah, x bar dot y bar, the dot product is magnitudes of both of these vectors into the cosine of the angle between them. Now, this is a geometric definition, but rarely do we really know the angles over here. So rather, if you look at the algebraic definition, this would be just x1, x2 plus y1, y2. So something like, summation of I is equal to 1 to 2 xi, yi. And if you've got more dimensions over here, the same thing can be done. So this is your dot product. And should we do the intuition? Yeah, let's see what it means. What does dot product really mean, right? So dot product is trying to tell you how parallel or how much of each vector is going in the same direction as the other vector. So if you actually look at cos theta, it goes from values like cos 0 is 1 and cos 90 is 0 and cos 180 is minus 1, right? So if these two vectors were perpendicular to each other, that is, none of them are going in any ways as the other is going, then you would see that since it's 90 degrees, cos 90 is 0 and then the value becomes 0. Whereas if these two are kind of parallel and then cos theta over here where theta is equal to 0, then you see that cos theta gets its maximum value. That's 1 over here, and then this also gets its maximum value. So what is this? Finally, dot product is a scalar. It's just a number, right? It's just a number. That's what it gives you. Even from here, you would see that you would just get a number. So this is your dot product. Now let's quickly see what's the cross product, right? X bar dot y bar. This is pretty similar so far, but only problem is it is sine theta. That's the difference, right? And if you look at sine theta values, at 0, sine 0 is 0, sine 90 is 1, right? So at the maximum value, when the vectors are perpendicular to each other, you get the maximum value. So it is kind of, so the intuition behind the cross product is that how perpendicular are these two vectors to each other, right? So if you get 0 as a value of your cross product, then you know that these two vectors may be actually parallel. And if you get 1 over here in your dot product, you will know the same thing, that these two vectors are parallel. I don't know if I'm confusing you more than needed, but yeah. So this is a sign of how parallel, forgive my spellings, and this is how perpendicular or orthogonal are they to each other, right? So this is what it is. But one more thing I forgot to say is that the cross product is actually not just a vector, it's not just a scalar, it's not just a number that you get, but it has a unit vector or the direction, let's say n hat, or here along with it. And the direction of the cross product is actually a vector which is perpendicular to both of these, right? And the only way you can get a vector that's perpendicular to both of these is to come out of the plane that they lie in. And probably over here, the vector is shooting into the plane, right? So there's something called as right hand rule, and you can put your index finger on X, and the first vector, the middle finger on the second vector, and your thumb would be giving us the direction of the resultant vector. So some places x bar dot y bar over here, this is actually called as a pseudo vector. So this is also a vector, and sometimes it's referred to as pseudo vector. So yeah, so we have seen the definitions of dot and cross products. We have also seen what they actually mean. Thank you. But hang on, we could see some properties of dot and cross products. Before leaving, we could see some properties of dot and cross product. So for dot products, they're commutative, so a dot b is equal to b dot a. Cross products are actually anti-commutative, so the cross products a cross b is equal to actually minus b cross a. Right, so it's anti-commutative because the direction of the vector will change. That's it.